What's up, class? Hey, how you doing? It's Mr. Troop. You may not recognize me. It looks shockingly handsome with my mustache. That's right. We're quarantined, and I don't gotta be anywhere for a while. So I figured, you know what? You know, sport the mustache for a little while. You know what I'm saying? So enjoy. I know I look fantastic. All right, guys. I got a math problem here. Let's see how to do it. Okay. Let's see if this works. Oh yes, we are live. All right. Here we go. Okay, so I have this alternating series. Notice the signs, they're alternating. Negative, positive, negative, positive, negative, positive, and so on and so forth, okay? So if I have an alternating series, I'm simply just gonna throw a -1 to the power of n or a -1 to the power of n plus 1. Now, this is going to start negative, and this one right here is going to start positive, okay? If we have a -1 to the power of n, it's gonna be a negative term, then a positive term, then negative, then positive. If we have -1 to the power of n plus 1, we're gonna start out positive and go positive, negative, and so on and so forth, okay? So I'm gonna go ahead and write out the summation notation for this series. So here we go. I have the summation from n is equal to 1 to infinity. And well, if I notice, this is really like -1 over 1, 1 over 2, 1 over 3, 1 over 4. Pretty simple. You're going to realize it's just a 1 over n. -1 to the power of n times 1 over n. Okay? And that's the series we got. Ooh, man, I wrote it out of my range. I don't want to move my camera. I can't just click it like on the smartboard. How dare I? I'm so ashamed of myself. Sorry, let me fix that. There we go. Better. Okay. So now I want to determine if this series converges or diverges. So we're on page 107. This is the alternating series. Now, we're going to look for a couple of things, okay? The first thing, I want to look for the limit as n approaches infinity of my equation. I don't need the -1 to the power of n portion of this. I just want to look at the meat and potatoes, the bulk of it, all right? So I want to say, does this equal 0? I want it to equal 0. Does this equal 0? Yes, that's fantastic. This is really, 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 really good stuff, okay? Now, the next thing I want to do is I want to analyze 1 over the next term, so n plus 1, and 1 over n. And what I want to find is I want to find that 1 over n is in fact larger. Now, the way I always do this, guys, I just choose. I'm going to say n is equal to 2. I just pick 2. You pick any number you want to. And I say, okay, 1 over 2 plus 1 and 1 over 2. Well, that's 1 over 3 and 1 over 2 is 1/3 smaller than 1/2. If you remember this trick from like grade school, you can cross multiply 2 times 1 I get a 2, cross multiply 3 times 1 I get a 3. That'll tell you which one's bigger. 3 is clearly bigger, 2 is clearly smaller. Is this a true statement? Yes, it is, okay? So if both of these scenarios happen, the limit is the equation goes to infinity equals 0, and 1 over n, or and the n plus 1 term is smaller than the n term, then I guarantee you we will converge. Okay? That will be converge. All right? So let's look at another one. Okay? Let's look at the next problem in our notes. All right, so the second problem in our notes looks like this. It's already written in summation notation, which is fantastic. Okay? I have the summation as n is equal to 1 to infinity. I got -1 to the power of n plus 1. Okay, that tells me one thing. That tells me we're going to start positive. That's all it tells me. That's all I need to know. And I got n over 2n minus 1. Okay, now in your notes, I want you to kind of write out some of the series, expand it a little bit, write out some terms. So sure, why not? We know it's going to start positive. So if I plug a 1 right there, that's going to be 1 over, well, 2 times 1 is 2, minus 1 is 1. So it's going to be 1 over 1, which is 1. Positive. Then we're going to alternate to negative. It's going to be 2 over 3. Positive. Then we're going to plug in 3. So we get 3 over, it looks like 5. You kind of see my drift. Oh no, hold on. My phone, oh, it's because my battery's dying. Are we back? Okay, yeah, we're good. Technology issues. So we can expand the series like that if we want to. Okay, let's do our step-by-step process. So step number 1, let's do the limit is n goes to infinity of n over 2n minus 1. Now, right away, this is an infinite limit. We're looking for horizontal asymptotes. We see the exponents are the same, so we're going to divide my coefficients. It equals 1/2, and 1/2 is most definitely not 0. This is kind of like telltale end all. This means we're going to diverge. Okay, meaning our series is going to grow and grow and grow for the rest of eternity. It's never going to get close to one specific number. Now we should go ahead and show the n plus 1 term being larger. So I'm going to do that. So I'm going to take the n plus 1 term over 2 times n plus 1 minus 1. And I'm going to show, is this smaller or greater than n over 2n minus 1? Just like before, guys, I'm going to take a quick little n is equal to 2. And that's going to give me 3 over 5. And that's going to give me 2 over 3. I'm going to do my nice little cross multiplication trick. That's going to give me a 9 when I multiply over there. That's going to give me a 10. Is this true? Is 9 smaller than 10? Yeah, so is 3/5 smaller than 2/3? Yeah, that did happen. But because this did not happen, my series is divergent. I need them both to happen for it to be convergent, okay? All right, fantastic, okay. Let's do one more. Let's do one more. I'm gonna do the next one in our notes. All right, so we have the series from 1 to infinity of -1 to the power of n plus 1. I got n plus 2 all over n, okay? I'm not going to expand it. I don't really want to. I just want to know if it is, oh, it tells me. It says the series diverges. Explain the reasoning. Okay, well, that's fantastic. I'm just going to go through my 2 steps, okay? I'm going to look at the limit as n approaches infinity of n plus 2 over n. That's my first step, okay? If this equals 0, then I have to do the next step. If this equals something else, that's the reason, okay? So here we go. This has the same exact exponent, so power of 1, power of 1. We're going to divide my coefficients, 1 divided by 1. What is 1 divided by 1? Well, it's 1, and 1 does not equal 0. So this diverges because of this reasoning, okay? If that did equal 0, I would have to do the next step. Look at the second term and the first term, see which one's bigger, okay? Fantastic. All right, guys. Doing great so far. We're going to look down here at the bottom of our notes page. We're going to talk about a Lagrange remainder for an error bound. That's a lot of big words, okay? Flip back in your notes, look through the Taylor polynomials if you'd like to. When we talk about alternating series, this is a very simple concept, okay? So here we go. I have this series right here. N is equal to 1 to infinity. I got -1 to the power of n plus 1 all over n factorial, okay? Well, let's list a couple of those out. Remember, this means right here that we're going to start positive, okay? So when I plug in a 1, I'm going to get 1 over 1 factorial, then -1 over 2 factorial, then positive 1 over 3 factorial, then -1 over 4 factorial, positive 1 over 5 factorial. The question asked you to use your first 5 terms. That's why I did 5 terms, okay? Now, if I'm going to do it this way, I'll try to hook it up just a little bit. There we go. Okay, these factorials, y'all remember, like 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1, okay? These are getting smaller and smaller and smaller, but they are alternating, okay? If I use these first 5 terms and I actually calculate it, I've done that in advance for you guys. It's going to be 0.633, and the 3's are going to repeat just forever, okay? Now, for an alternating series, only for alternating series, the error is the n plus 1 term, okay? Well, what is my n plus 1 term if n is equal to 5? N is equal to 5, n plus 1, oh, I'm like jumping ahead of my brain. N plus 1 is equal to 6, so my n plus 1 term is just going to be 1 over 6 factorial. Again, very, very, very small number. Actually, sorry. It's going to be negative 1 over 6 factorial. Very, very, very small number. When I take that number and I add it to my series, I'm going to get 0.63. And this would be a calculator problem, obviously, you guys. Okay, so this is my error. And a range is just adding that error to account, okay? I probably should write all this. I'm kind of running out of room. You would normally write the rest of your equation right there. I'm running out of room. Okay, so this right here would be my range for my series, okay? All we have to do is find the next term, subtract that from where we were. Again, 1 over 6 factorial is very, 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 very small. It's like 1 over 720, I think. Very small. So all we have to do is take that small number, negative small number, add it to that. We get this number. That's the bottom side of our range. This is the top side of our range. We have an error in between. Makes sense. Okay. Awesome, guys. We're doing great. The last thing we're going to talk about on the back side, this is going to be on technically on page 108 now. We're on page 108. We are going to talk about absolute convergence, okay? So I want to say if a series, some series A sub n converges. Oh, sorry. I should probably write all this. It's hot in my garage. I waited way too long. I should have done this video at like 8 a.m. I'm sweating. Okay, we're going to look at its absolute value, the absolute value, meaning it's always positive. So if we're dealing with alternating series, the absolute value of an alternating series is not an alternating series. It's not, because it's always positive. Alternating series goes positive, negative, etc., okay? So we're going to say if this converges or diverges, we're going to say, does this converge or diverge? Okay. Some easy facts. If this, the absolute value, if that converges, then the normal series has to converge. Okay, I should probably write those in there. So if the series, that the absolute value series converges, then the normal series has to converge. That's a fact. Other way around, not so much. Okay, so let's dive into one of these problems. Okay, the first problem we are going to look at here, it says determine whether each of these series converges conditionally, converges absolutely, or diverges. Converges conditionally. That means that the series A sub n converges, but the series of the absolute value is diverging. Okay? And then converges absolutely, what do y'all think? Yeah, if it converges absolutely, it means they both converge. Very good. And then obviously, if the initial series diverges, then it's a divergent series. We don't need to look at the absolute value, okay? All right, so the first problem they give me, pretty simple. I have the series from n is equal to 1 to infinity. Oh, sorry, 0 to infinity, it looks like. -1 to the power of n, n squared over n plus 1 squared. So the first thing I'm going to do is I'm going to test this alternating series for convergence. And the test for alternating series is I'm going to look, obviously, at the limit as n approaches infinity of n squared over n plus 1 squared. I have the same exact exponent. So I'm going to look at my coefficients. I have a 1 coefficient and a 1 coefficient. So this limit equals 1, which is not 0. This is a divergent series. It diverges from the get-go. We don't even need to look at the absolute value. This is just divergent, okay? All right, let's look at number 2. I have the series from n is equal to 0 to infinity, -1 to the power of n, and then I got an 8 over square root of n plus 1, okay? Awesome, the first thing I'm gonna do, I'm gonna look at the limit. As n approaches infinity. Okay, so I have a number on the bottom, on the top. So 8 over, I'm gonna write this very simply. I'm gonna write n plus 1 all to the 1/2. So it does have an exponent. Properties of horizontal asymptotes is if it's bigger on bottom, it's 0. This does equal 0. Okay, that's my first check mark. That means I have to go to this next step. I have to go to this next step. I'm going to look at the second term. So 8 over n plus 1 plus 1. And I'm going to look at 8 over n plus 1, right? And I'm going to see, is this in this relationship? Is the second term smaller than the first term? That's all I want to see. Are my terms shrinking? That's all we care about, okay? So if I look at it this way, well, like I do, I'm going to say n is equal to, let's go 2, right? So if I plug that in, I'm going to get 8 over the square root of 4, and we get 8 over the square root of 3. Now, if you need to break it down, these are usually calculated problems, help you see it out a little bit. That's 8 divided by 2, and that's 8 divided by 1 point something, right? Yeah, like 1.7-ish, right? Which one's going to be bigger? This one's going to be bigger. This is true. So this means that this alternate series converges. That's fantastic. We have a converging series. But what this means now we need to look at the absolute value, okay? So if I did the absolute value, I'm gonna do this in a way that makes sense to me. Hopefully it makes sense to everybody watching, and it's on YouTube, so hopefully it makes sense to like the YouTube world. Hopefully I don't get called out in the comments. I looked at the absolute value of that. In my mind, that just says, okay, now everything's positive. That just tells me we don't need this -1 to the power of n. So I'm going to do n is equal to 0 to infinity of just 8 over the square root of n plus 1. That's all I'm going to do. Now, if you look at this, hopefully from the last video notes, you'll recognize this to be a p-series, right? It's in this form of like 1 over n to the power of p, where my value of p in this current equation is 1/2. It's written a little tricky because square roots, if we remember, they can be written as a 1/2 exponent. And we know that since 1/2 is between 0 and 1, well, I can't equal 0, yeah. So since 1/2 is between 0 and 1, this is a divergent p-series. So since the first problem converged, but then the absolute value of that problem diverged, what can we say about the convergence overall? Well, it's going to have conditional convergence, okay? It's going to have conditional convergence. All right, great work today, guys. Great work. Very, very, very good stuff. Again, if you have any questions, please reach out, call me, email me. Your homework, 6.2 for a grade that you need is going to be page 109. We're going evens. Page 109 evens. Turn it into Canvas, just like we did the last time, okay? Turn into Canvas. There will be a Canvas submission. Oh, my battery is dying. Hopefully you guys can still see me. Hopefully my sound has been on the whole time. I think it has been. We're gonna go with yes. Awesome, guys. That's all I got for y'all today. It's been a pleasure chatting with you guys. Hopefully you guys are learning stuff, staying safe, staying inside, flattening the curve. Hopefully you guys think my mustache is pretty cool. I'll tell you right now, my wife does not, but that's okay. Y'all have fun. Enjoy your quarantine. This is Mr. Troop, signing out.